Okay, if you look at our foldable today, we're going to talk about the first topic, which on here is greatest common factor. So this is Unit 10, has to do with factoring. We're going to go ahead and talk about greatest common factor. Okay, so our first slide of our notes. We want to talk about greatest common factor in factoring. The first thing we want to talk about is what a factor is. So if you look up here, it says a factor is a number that another number is divisible by. So a number that another number is divisible by. So I have two numbers up here. I have 8 and 20. Sometimes the easiest thing to do, rather than think of what is 8 divisible by, is to think of what multiplies to give you 8. Because whatever multiplies to give you 8 is also going to be divisible or go into 8. So let's look at that. So some numbers that multiply to give you 8 are, of course, 1 and 8. 1 and 8. And another pair I can think of is 2 and 4. So 2 and 4. So you can say that 1, 2, 4, and 8 are all factors of 8 because they divide into it evenly. 20. Numbers that divide into 20, I know, of course, 1 and 20 go into 20. Okay. Another pair would be 4 times 5 is 20, and 2 times 10 is 20. So 2 times 10 is 20, and 4 times 5 is 20. So those are all factors of 20. So if you look at the word greatest common factor, greatest common factor, there are 3 words there. Okay, if you look at greatest common factor, greatest means the largest. Okay, common means what they share, and factor are numbers that divide into it. So the largest number that they both have in common that's a factor is 4. So your greatest common factor of 8 and 20 would be 4. Okay, our second slide of our foldable has a few other examples. Some of them have variables. Now I want to show you a few things to think of or a few tricks to talk about for it. So the first one, 24 and 84. Okay, you could make a list of all the numbers that divide into 24 and all the numbers that divide into 84. And you could find the biggest one that they share or have in common. However, that may take you a little while. So here's another trick to find the greatest common factor of 24 and 84. First off, make a tree, a factor tree for 24 and 84. So if I do that real quick, 24 I know is 6 times 4. So at the bottom of my trees, once I get to prime numbers, I circle them so I don't keep going. Okay, so there's the prime factorization or the factors of 24, the prime numbers. So if I multiply 2, 3, 2, and 2, that should give me 24. You can always check if that's right that way. 84, let's see, 4 and 21 is 84. 4 is 2 and 2. 21 is 3 and 7. So that should be the prime numbers you can multiply to get 84. Now, what I know is if I can multiply all of those and get 24, then each of these prime numbers at the bottom should also be able to divide into 24. Same with 84 is true. So what I can do is I can find the numbers that they have in common and multiply them together to get the greatest common factor. So notice how both 24 and 84 have a 2. Both of them also have a 3. And both of them also have another 2 in common. If you multiply their common numbers, you can figure out that 12 is the greatest common factor. So I'm going to write that up here. Okay, our next example. I have 3 terms. 14n squared, 35 into the 4th, 42 into the 5th. Okay, the greatest common factor of 14, 35, and 42. If you don't know what it is, you could make a tree. Okay, here's another easy way you could do it. Pick the smallest number of the group, which is 14. Okay, I can use the factors of 14, okay, to see if they go into the other 2 numbers. And the largest factor of 14 should also be the largest, greatest common factor of all the numbers if they go into it. So 14, numbers that go into 14 that are factors are 1, 2, 7, and 14. Okay? So out of that group, Does 14 go into 35 and 42? Okay, it does not. Does 7 go into 35 and 42? It does. So 7 should be the greatest common factor, the number part of those three numbers. Okay, I can't have a number bigger than 14, so that's why I looked at the smallest one. Now, the other part of it. Okay, the first term right here, 14n squared, that has 2 n's multiplied. 35 into the fourth has 4 of them multiplied, and 42 into the fifth has 5 n's multiplied. The number of n's all three of those have in common is the smallest amount, which is n squared. Okay, all of them at least have 2 n's, or n squared in it. So that should be your greatest common factor. The next one, 21x cubed, 18x squared. Okay, this one's pretty straightforward. Okay, the greatest common factor of 21 and 18, okay, if you were to write them out or make a tree, should be 3. Okay, and then they both have at least an x squared. They both share at least 2 x's in common. So an x squared. The last one, 7y squared and 9z squared, sorry. The biggest number that 7 and 9 have in common is actually 1, because 7's a prime number, okay? And 9's not divisible by 7. Do they share any y's? Okay, 9z squared doesn't have any y's, so they don't share any y's. 7y squared doesn't have any z's, so they don't share any z's. So your greatest common factor on this one is only 1. Okay, last slide in this foldable for your notes. Okay, we're actually going to factor out the greatest common factor. So notice how it says factor out the greatest common factor. So what that means is I need to find the greatest common factor first, and then I'm going to pull it out of the whole equation, okay, the whole problem. So let's look at number 1. We kind of already did this problem in the one before. The greatest common factor of 24x squared and 84x, from what we did before, the greatest common factor of 24 and 84 is 12, and they both share an x in common. So what that means, since 12x is the greatest common factor, it means it will divide evenly into both terms that I have. So to factor it out, okay, you're going to pull it out of both terms by dividing. So I know 12x is going to divide into both of them evenly. Okay, so I'm essentially taking it out of both terms. When I take it out of the first term, 24 divided by 12 is 2. X squared over x. And x cancels out on the top and bottom, and you're left with just an x. Okay, so I'm done with that part. Then you have the plus. 84 divided by 12 in the second term ends up being 7. And both of your x's cancel out because there's only one on the top and bottom. So the factored form of it, when you pull out the greatest common factor, is 12x, and then in parentheses, 2x plus 7. The second one, the greatest common factor of 6m squared and 15m is 3m. So again, that means 3m will divide into both of them evenly. So if I take a 3m out of both of them, if I take a 3m out of the first one and divide, I'm left with 2m, and I have my minus, and 15m over 3m, when you take that out, divides out to just give you 5, because the m's cancel. Okay. Right, the third problem, the greatest common factor of 4x cubed plus 8x squared plus 12x, those three terms, the greatest common factor is 4x. Okay, 4 is the biggest number that will go into 4, 8, and 12, and they all have at least one x. So I'm going to take that out by dividing each of them by 4x. When I do that, on the first term, the 4's cancel. Okay, an x cancels on the top and bottom, and you're actually just left with an x squared. On the second term, 8 divided by 4 is 2, and then only one of the x's cancel. So you're left with 2x. And then on the last term, 12 divided by 4 is 3, and the x is canceled, so you're left with just 3. So that's what that one would factor out to. And our last problem. Your greatest common factor of 12x and 6 is just 6. Okay, they don't have an x in common, so it's just 6. So if I take a 6 out of both, if I divide both of them by 6, the beginning, the first term, 12 divided by 6 is 2. I still have the x there, it didn't cancel. And then 6 divided by 6 is 1. Okay, and that concludes the greatest common factor for the first part of your folder.